Okay, so we just finished learning about the parent graphs, exponentials, and logarithms. So my next task is I want to see if you guys can take these equations and match them with these graphs. So let's pause the video for a little bit and spend maybe 5 minutes trying to match these equations with these graphs. So there's some key features that you could look for here in the equation that might give you a hint as to which graph it goes with. So let's pause that for a couple minutes, let you guys talk about it. When you feel like you're ready, push play again, and I'll talk to you about how these graphs are shifted from our parent graph. So go ahead and have a conversation about that. Okay, so I'm assuming that we took some time to kind of figure out what these graphs do. So the first thing I want to point out is that 3 of these equations, this one, and this one, all look like exponentials. Reason why? The exponent is up, the variable is up in the exponent. So that's an indicator that this is going to be in the exponential family. Okay? So what does the exponential parent graph look like again? Looks something like this. Okay? So if that's what the parent graph looks like, remember the key features. We have a horizontal asymptote. We have a point at 0, 1. Okay. So maybe over here on this graph, let's look for some of those graphs that have a horizontal asymptote. I think A, C, and F all have a horizontal asymptote. So I think that these first 3 go with these 3 graphs, A, C, F. And I think that's because they are in the exponential family. Sweet. So these 3 go with these 3. Well, how do I know which one goes with what? Well, do you guys remember learning that if I have a +2 here, that's going to shift my whole graph left 2, and this -3 is going to shift the whole graph down 1. So if our regular graph, our normal parent function, has a point at 0, 1, I'm just going to write that on all 3 of these. Which one does it look like takes that point and moves everything left 2 and down 1? So let's see. Left 2, down 1. That means there would be a point here. There's not. So I don't think that this one's A. What about this one? Let's see. Left 2, down 1. So it could possibly be this one. And let's look at this one. Left 2, down. Oh, what am I thinking? 3. Okay, back up. This would not be down 1, it would be down 3. Okay, let's go back and try that again. So it'd go left 2, down 3. Okay, so that still can't be it. That's from here. Left 2, down 3, still can't be it. And this one, left 2, down 3. Hey, there it is. So it looks like this graph, F, is the one that goes with this equation A, because if I look at my parent graph point right here, it looks like it moved left 2, down 3. So I'd say that little a, this equation over here, oops, guess I gotta like undo a lot of dots here. Okay, now we're back. I think that this A goes with this F, so maybe I'll write capital F right next to it. Okay, well, let's look at this next one. I see a +2, a +1, and a negative in front. So what does all that do? Turns out if we have x plus 2 together like this, that's going to move it left 2, sort of like we did on this problem. This +1 is going to move it up 1. And this negative is going to reflect over the x-axis. I'm going to give you guys a note guide here in a second. See this? That'll help you guys and I'll make sure that everybody has a copy of this video or the link to the video so you could come look here at these sort of cheat sheet things. Okay, so let's look, and we already eliminated this one as an option. So between these two, which one does it look like if I start here at my point 0, 1, which one looks like it goes left 2, up 1, and then reflects over the x-axis? Let's see. If this goes left 2 and up 1, and I reflect it, I think this point ends up going here. So I think we missed it. On this one, if we go left 2, up 1, and then reflect it, let me see actually. I think maybe we have to reflect it first. Yeah, okay, back up. So what we're going to do is we're going to take this point here. We're going to go reflect first. So that will be here now, because this is my mirror line right here. Reflect it this way. And then I'm going to go left 2, up 1. It looks like that really did work out. Another key is that reflect over the x part. The reflect over the x-axis would mean I'd have a shape like this rather than a shape like this. So that's a hint. On the homework, you guys are just going to have to match graphs sort of like this. So we're just looking for key features in this equation. Okay. So it looks like little b goes with graph C. Now what about this one over here? What do you suppose that minus 2 does? If this plus 2 makes it go left, 2, then this minus 2 must move it right 2. And what do we think about this minus 1? I think that moves it down 1. So we already used that one. So let's just double check that this really does work. So if I have that point 0, 1, and I move the point right 2, down 1, do I hit the graph? Right 2, down 1. Looks like I do hit the graph. So I think this equation right here goes with graph capital A, like that. Okay, so these are all used. And if you notice, these three equations, I don't think we've seen ln yet, but that's just the same thing as a logarithm. It has a different base. We could talk about that when I get back. So this ln, I still want you to think of this as a logarithm. And remember over here, we said the logarithm graph has a key feature, has a vertical asymptote, and usually starts with the point at 1, 0. So B, D, and E, if we look closely, they all have a vertical asymptote. So that should be an indicator that all three of those are part of the logarithm family. So let's explore a little closer. What does it mean when I have plus 2 attached to my x? Well, that's similar to this rule here where it said plus 2. I think what that does is moves my graph left 2. My normal point starts at 1, 0 for the logarithm. I think that's right here. 1, 0, 1, 0, 1, 0. So which one seems like it makes the most sense that it just took the original logarithm graph and moved it to the left 2. So it'd be like move this point left 2 like that. Let's check. So if I move this one left 2, I miss my graph. So it's not that one. If I move this one left 2, I miss my graph. So it's not that one. If I take this and I move it left 2, look at that. I hit the graph. So I think that E is the graph of part D here. So we use that one. We could use our elimination here. And what does it seem like is going on here? Okay, so this plus 2, if we want to think of it like this, if we have 2 plus natural log of x, that's just what that's called. That's the same as natural log of x plus 2. So what does the plus 2 do? I think we said over here the plus 1 moved it up 1. So this one's going to move everything up 2. So here we go. Here's our two options again. So if I take this point and move it up 2, I missed the graph, so it can't be that one. If I take this point right here and move it up 2, I hit the graph. So I think that this graph is D. Well, that must leave this one to be B. Let's see if we can figure out why. So that +2, we said, moves everything up 2. And what if we have a negative inside of here? We're changing a negative here. That's going to reflect over, let's see, the y-axis. So instead of this shape, we would get this shape, which it looks like we have. And so when I reflect it, my point would go from here to here. And then if I move it up 2, I end up hitting the graph. So I think this is the correct graph for function f. So hopefully that helps. On the assignment, you guys are going to be given equations like this and have to either describe the transformation, so you'd say like left 2 up 1, or use a reflection, etc. And I think you'll have to match equations to the graph. So we'll see how you guys do. I think you'll do okay, and if you don't, it's all right. I'll come back and help you guys understand this better. But here, let's look at this. This is like a cheat sheet. If you guys notice, this whole section helps us with an exponential type problem, and this whole section helps us with the ones that have logarithms in them. So, like this says, so if I do a -3 with my x, what does that say that I'm going to do to the graph? Looks like I'm going to shift everything 3 to the right. And this one, if I have a +2 with the x, it does almost the opposite of what you think, and it moves it left 2. What if I have something added or subtracted on the outside of my function? That's going to either move it up or down. What if I have a negative in here with my x? It looks like that reflects over the x-axis. But if I have a negative out front, it reflects over the x-axis. These rules should seem really familiar, like when we talked about radicals. This was the same thing, right? Didn't this still move it right too? So those rules should really match up. Okay, these ones are the ones that are a little bit trickier. But basically, if you put a number in front of the x, so this could also be thought of as 4 to the 1/2 x. So if we put a number in front of the x, it's going to shrink or stretch horizontally, which is this way. So we're either going to bring it in closer, tighter, or we're going to stretch it out more horizontally. But what if we put a number out front, like a 1/3 or a 1/4? That is going to stretch vertically. So if you notice, these rules are actually the same for logarithm too. If I put -4 here with logarithm, it's similar to -3 up here with exponential. It's going to move it 4 right, left 7, up 3, down 1. Here's our negative inside with the x, that reflects over the y-axis. Negative out front reflects over the x-axis. Number with x is going to stretch it horizontally. Number outside is going to stretch it vertically. So I'm going to send you guys all an email, and I'm going to send the link to this video to all of you. So if you want, what you can do is just pause on this page while you guys do the homework. You can flip back and forth between your big ideas assignment and this note page. And I think if you guys had this, you'll be able to rock the assignment. If you don't, when I come back next time, we can chat about it and make sure that you guys understand this all really well. So let me erase all this crap that I wrote on here, so this could be nice and clean for you guys. Maybe this is where you want to pause it so it looks all nice. Okay, I think, if I'm remembering, oh, there's one more thing I want to talk about. So before, what we were doing is we were starting with the equations and matching it to the graph. But what if I give you an equation like this and some instructions? I'm wondering if you guys can write the equation. So it says start with this, f of x equals 2 to the x. So I'm going to write that. And I want to do a couple things. I want to move it 4 to the right and reflect over the x-axis. So if I go back to this page, how do I move something to the right again? Oops. It looks like I just need to put -3 with my x. So I'm going to go back, and instead of just writing x, I'm going to write x minus 3. That's going to tell me to go right 3. Okay? And then how do we reflect over the x-axis? Let's look for it, reflect, x-axis. Looks like what we need to do is put a negative out front. So over here, what I'm going to do is I'm going to put a negative out front. And these two things, this is going to reflect over x, and this is going to move right 3. So this equation, f of x equals negative 2 to the x minus 3 power, is going to make these changes. So you basically start with the equation they give you and see if you can make adjustments so we'd get to something like this. What if we start with logarithm like this? That's what I'm going to start with. It looks like we're doing base 1/3. Who cares? It's okay. And then these are the instructions here. We need to go 2 up and a vertical stretch by a factor of 2. So let's go back to our page over here. And let's look for up 2. I'm going to erase this stuff real quick. So up 2. Let's see. So up. It looks like we need to plus that number on the outside. So if I go back to my equation, I think the first thing I need to do is put a plus 5 at the end, because this is going to move it up 5. And then how do I do my vertical stretch by a factor of 2? Let's see. Vertical stretch, if we want to do it by a factor of 3, we put a 3 in front. So if I want to do a 2, then I'll put a 2 in front. So let's go back to my example. If I want to do a vertical stretch by a factor of 2, I'm just going to put a 2 in front. So this makes me have a vertical stretch by a factor of 2. So this is the equation that makes us go from this original function to a function that's 2 units up and vertical stretch by a factor of 2. Why did I write up 5? Hold on. I think that was supposed to be up 2. My bad. Turns out making videos is a little harder than it seems. So this is up 2, and this one's a vertical stretch by a factor of 2. So I think there's a couple of assignments on your questions on your assignment that ask you to write out an equation like this. So this could be a couple examples for you. I know some of you guys like to do the assignment on a piece of paper. So here's the assignment here. But turns out this assignment's much easier if you do it on the computer, because then you just have to match. Otherwise you have to draw graphs by hand, and I found that students don't really love doing that. So your assignment is on bigideasmath.com, and it's just going to be 5.3. That's how you're going to find it. So let's see how you guys do. Try your best, really try. Work the whole class period or until you're done. And then when I come back, I'd be happy to answer your questions. So I'm going to email this to everyone so you can have access to it. In case I went too fast, you can watch it again. But I think you guys are going to do great. Good luck.